Okay, so I reckon that I've got 20 seconds until I'm due to talk, but you know, why not start early? So, I'm going to start by telling you a little bit about myself. I guess a lot of you here already know me because I'm a regular at these events. My name's Tom Hukins. I'm a Perl consultant and developer. So if you could do with a consultant developer helping you out with stuff, please get in touch with me. So, this talk is called Escaping Insanity. What do I mean by that? Well, we use escaping to kind of escape special characters. And it can be a bit annoying sometimes, because if you've got things within other things, and then within other things, and then within other things, you end up having to escape things. And it's very easy to make stuff unreadable, incomprehensible, confusing. So that's essentially what this talk is about. And I've broken the talk up into 3 sections. I'm going to talk about some of the basics of Perl that I think relate to this. Then kind of vague sort of concepts and abstractions that help set the scene for this. And finally I'm going to talk about some of the approaches you can use in your Perl code for kind of mitigating escaping, avoiding it where possible, or making it more pleasant where necessary. So, some Perl basics about escaping. Here's a really simple program. And whilst a lot of the stuff I'm going through here is really basic, I'll build on it later, so, you know, bear with me. Say $name here outputs the value of $name because it's a variable. Okay, we're comfortable with that. If we put it in single quotes, however, single quotes don't interpolate, so the variable doesn't get output. Instead, we see the literal $name. Another thing we can do within the quotes is mix the variable and some text. So if we have the text A and the variable $name, what we see output is this pattern. Okay, so that's all fine. But what if we want to put the A on the end of the string? Well, this doesn't work because Perl will see $name A and look for variable name A, which doesn't exist, so it doesn't output what we'd hoped. So one way of dealing with this is to break up the variable and the literal text. We can use the dot concatenation operator to put the A on the end. Another thing we can do is delimit the variable. Curly braces after the dollar show us what the name of the variable we want to use is. So instead of concatenating strings, we're putting the variable and the literal text in the same string. Okay, so that's the basics. Moving on, what if we want to use our delimiter within the string itself? So if we've got these, if we want to output double quotes, well, because the double quotes are our delimiter as well as the content, that doesn't work. We can't use the same thing as both. So this is where escaping comes in. We escape the delimiter within our text, and now we get Tom says hi output by escaping that. But earlier we saw that escaping can look a bit messy when you have lots of it. So it's nice to avoid it sometimes. So, okay, what if instead of having the double quotes as our delimiter and our text, we use a different delimiter? Well, if we switch back to the single quote, of course single quote doesn't interpolate, so now we get $name says hi. Although we don't need to escape the double quotes anymore, we still see them. So that's annoying. Perl has what are called quote-like operators. And QQ is an example of a quote-like operator. And what QQ does is it allows you to replace the standard double quote operator with something else. In this case, I've used parentheses. Perl has lots of quote-like operators. There's Q for the single quote, QX for executable, QR for regular expressions, and you can go learn more about these quote-like operators. But the neat thing here is, although I've used the parentheses, the round brackets, if you had them in your text, you could use something else. You could use the curly brackets instead. Now, you can use anything as your delimiter here, but be careful. It's very easy to use, say, a letter, plain text character as your delimiter, and then people scratch their heads because it doesn't stand out. Using something like brackets makes it clear, makes it easier for the reader's eye to see what you're doing. Okay, so that's basically the idea of combining together variables and strings and escaping things where we need to. So it's nice to avoid escaping when possible, and there are various approaches to that which I'll come to later, but the bit I want to talk about now is kind of some of the abstractions we encounter in computer programming. and why escaping helps with those. So abstractions are basically different layers of stuff. We're kind of building up from the basics of computing to the higher level. So, for example, a bit in digital information, a 1 or 0 is our lowest piece of information. We build these up into bytes. And it used to be that we could think of bytes as characters. When we lived in an ASCII world, you know, every byte and a character mapped. And for the purposes of this talk, I'm largely going to pretend that's still true, although we know it isn't, but hey, we've only got 20 minutes. But so bear in mind that a byte is not the same as a character, but kind of go with, it's going to make this talk a lot easier to follow if we pretend that, so I apologise for lying to you all. And of course, what we work with when we're programming usually is streams of data, perhaps a file on disk, perhaps a stream over the network. And these are one-dimensional sequences of bytes, byte, 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 byte. So there's no structure in here, no order. Well, there's an order, but there's nothing more than that linear order. But a lot of the time we want to work with something more structured, perhaps a text file. We've got 3 lines of text here. But a file doesn't have ideas of lines built in. So what we do in a text file is we kind of have special characters. Hexdump is a useful Unix command for looking at the contents of a file. So on the right we see our data, and on the left we see the binary data that corresponds to the text. And what we see in this text file are 3 0A characters. And 0A on the right here is a line feed character, and this is what Unix text files use for saying, OK, move on to a new line. So this is essentially a special character, just like we saw the quotes wrapping a string as a special character. This is another one. Perl helps you work with text files by being smart about whatever your operating system's line delimiter is. So we can have combinations of CR and LF. And if you're interested in all the varieties of new lines, there's a very long Wikipedia page, as there often is for this stuff, and you can go read that. But bear in mind that Perl, by default, will deal with what operating system you're running on. And if you're creating text files or reading from different operating systems, that's something to be aware of. Another thing we encounter is structured text. So we've got this kind of linear file, we've got lines within a text file, but we can also have special characters that delimit some sort of structure to the data. So XML, for example, has elements separated with angle brackets. It has attributes, and it has plain text within those elements. So here there's also other structured formats that build on top of text like JSON. But the key thing to remember here is that you've got this stream of bytes, the new line characters within that, and then the special characters like the angle brackets or whatever that kind of build the format on top. So the different abstractions, as I said, are all kind of layered on top of each other. Okay, so the last part of the talk is I want to discuss some approaches that we can use to dealing with all this in our code. And there's one kind of golden rule giving a talk: never show your audience a slide full of text. But hey, it's first thing in the morning practically, so here's a slide full of text to keep you awake. But I'll go through it slowly. What I want you to imagine here is that we're doing something like a simple web application where someone passes in an ID and then we output some HTML. Now in this case, because I kind of want to fit all this on one slide and I want the people at the back to still hopefully be able to read it, I'm kind of hard coding it. Oh, we have thumbs up from the back, that's cool, people can read it. We have an ID hard coded here, but I want you to imagine maybe we're getting this from a web request or something else in the world that's untrusted. Could be absolutely anything. Then we run an SQL query to get some details about this talk. We're going to pull back the speaker and the title. We'll run some Perl code to populate those variables, build up a URL for more information about the speaker, and then finally we'll generate some HTML that includes those 3 pieces of information: the speaker and the title from the database, and the link that we built ourselves. Okay, so aside from me to kind of committing the cardinal sin of a speaker, what's wrong with this? Well, it's a short piece of code, but it contains 3 different things, and there's more to it than that. But, you know, there are actually some serious problems in here, which I'll come to. But the separation of concerns is a big problem, because in that short piece of code, we've got 3 different languages, we've got 3 different things to care about. So people often use web frameworks, or even if you're not working with the web, it's helpful to have different classes, different methods, what different functions, no matter how small or big your code base is, separate out the different parts. And that means the maintenance programs, including you in the future, will thank you. So aside from all this being a big kind of jumble of stuff, there's something else wrong with it, and or several things wrong with it, and I'm going to talk through some of those. So here's the SQL query I showed. Now, I mentioned that talk ID is coming from the internet here. We're getting web requests in and then running this query. And if our lovely users only ever send us numbers, this is going to work just fine. As soon as they want to send us something that isn't a number, this might blow up. If they decide they want us to send us something that contains a semicolon and then drop tables, we have an SQL injection attack, which is, still one of the most common problems that we see on the internet today. So SQL gives us placeholders. If we build up our query like this, where ID equals question mark, we can then, in our Perl code, replace the placeholders with what are called bind parameters. And that means the database deals with the escaping for us. Because quite often what you'll see is people, when they're writing Perl code, will jump through all sorts of hoops, checking what's in talk ID, throwing errors, this, that, and the other. But rather than kind of validating data or stripping out data, it's easiest just to let the system itself deal with it, with this sort of structure. So SQL has placeholders, other things do. If the thing you're talking to has these things, then use them because they're helpful. It might be that you've got a really big SQL query and you don't want to write SQL by hand. It might be that you do want to write SQL by hand, but if you find that you don't, or you want to build up fragments of it separately, SQL Abstract helps you do that. And the way that works is it takes a data structure like this, and that builds the query, and on the last line the ID, the bind parameter, and then it returns you the SQL you want to run with the bind parameters in it, and the bind values. So this is a handy way of building up queries programmatically. There are also some systems, such as Elasticsearch, that instead of having a text-based query language, have a structure-based query language. So if you want to query Elasticsearch, what you do instead of writing a text query is you query it in JSON. So you are basically building up a structure much like SQL Abstract. And that structure-based approach to querying makes it a lot harder to do dumb things, and it means you can validate the structure more easily and manipulate it. So one way of avoiding escaping things is just to, rather than storing things as text, store them as some sort of structure. I showed in my example creating a URL using a text string, concatenating things together. Probably most of you are aware of the URI module on cpan, which is commonly used for this. I'd also like to recommend URI template, which is based on an internet standard that's used in all sorts of languages, all sorts of places, not just Perl. For example, your web browser's search toolbar almost certainly uses the same standard, and URI template is a Perl implementation of that, so check that out if you haven't seen it. And finally, we were generating the HTML within our Perl code. Lots of people use templating for this. Templating is a good way of generating HTML. It's not the only way. Also, sometimes people build up HTML programmatically. The important point is that you should have part of your system that handles HTML generation using whatever approach you consider appropriate. I gave a talk about 12 years ago on kind of different templating things for building up websites. And I keep thinking I should redo it because the web 12 years ago was a lot different to the web today. And a lot of people will advocate, here is the solution for generating HTML. What I suggest you do is think about the project you have, think about the types of problems your project is dealing with. Think about the people you're working with and choose an HTML generation system that fits that. It might not always be the same one. When you are generating HTML, it's really easy to end up with double encoding because you're trying to escape stuff. So what should look like on the first line ends up looking like what's on the second line. And if you want to spot problems like this, test double encoded entities on cpan will help you deal with that. So I've kind of shown you a problematic code example talked through a few problems to do with escaping. Now, you might be doing more than that contrived example. Perhaps you're writing a regular expression to check something. So here I might be taking like the name and checking it matches .check. Now, what's the problem with this? Again, if we're getting this data from unstructured sources, what if $check were to contain something like $star that matches lots of text and slows your system down? What if it were to contain some Perl executable code which you can run in a regular expression? Then, you know, we've got a security problem again. So when you're running untrusted code inside a regular expression, as we're doing with $check here, you need to escape it. And there's two approaches to this. You can either escape it within the regular expression with the Q&E delimiters, or you can use the quote meta command. So make sure you're very careful what you put inside your regular expressions, and if you're putting a variable inside, escape it. Now, operating with files is something we do all the time in Perl, and this is kind of a classic example of writing to a file. It takes two arguments. If you're reading from a file also, you might be using this two-argument open. But there's a problem here. The second argument is basically telling us two things. Firstly, it's telling us that we're writing to a file, and then it's telling us the name of that file. And one of the things about avoiding escaping, earlier I talked about breaking things up into structures. And the more that we can separate out different things from being within the same string, the easier we can avoid having to think about escaping. And I think that really is the key theme of this talk. And Perl so yeah, here's the two arguments. Perl for many years has had a three-argument open. Here it is. So what we're doing now is we're separating out the greater than, which tells us we're writing to a file, from the file name. So we've broken those two pieces apart. This not only makes the code easier to read, it avoids a whole load of security problems. So that makes that. Here's the same code again, but split onto 3 lines. And the reason I've split it onto 3 lines is to show you this. I mentioned earlier that a lot of this talk pretends that we're working with ASCII. Now this is my one kind of, hey, look, that is a lie, and I apologise for lying to you. But when you are reading or writing to files, use this 3-argument form and tell us what sort of file you're working with. Make sure that you're clear about what you're doing here. Just like when you're dealing with files, you might be using system calls to call external commands. And the way that you do this is you call system with your command. That gets passed out to your shell, and your shell then executes it. And if you wanted to supply the arguments to that command yourself, then you could put them in an array here, and that's going to work fine. Except, what if that arg contains something nasty? What if one of your arguments contains spaces? Well, then they're interpolating into this, and now you have to escape the spaces, but then what if there's a semicolon and someone runs rm-rf boot and stuff? Well, again, the system doesn't make us have to use one argument. We can use several arguments, which makes us happy. Basically, your first argument system should be the command you want to run, and then pass in everything else as a list. So that avoids a whole load of problems there, and it means we don't need to escape stuff, because it's done for us. So earlier I talked about these structured files. I used XML as my example, but other structured formats exist, JSON, yeah, stuff. There are kind of a few key things of when you're dealing with these structured formats. And the first thing is don't just do it in plain text. If you can sort of get away with templating or just concatenating a bunch of strings together to build XML. And it works sometimes, it works for easy stuff, but I would always suggest, if you can, use a module to generate this structured data. It makes life a lot easier. And also validate what you're outputting. XML comes with some really powerful validation approaches. XML schema is if you're working with people who use languages that are primarily IDE based, like Java and .NET developers, giving them an XML schema with the XML you give them makes their lives so much easier, because their tools auto-complete stuff for them. So again, think who you're working with. As Perl programmers, our tools aren't quite up there for XML processing. But anyone working with an IDE will thank you if you hand over code with a schema. And also, you can validate your output yourself to check that you haven't done anything dumb, to check that you haven't misescaped anything. at that level. JSON isn't kind of so strong on the validation side, but different things are different. Okay, so 20 minutes though. I've covered a lot of stuff. I hope some of that was helpful. But basically, so coming back to the key themes, I think the key themes are sometimes you need to escape stuff. Make sure you know when you do. And if you find yourself escaping, think about how you can avoid it. And if you can avoid it, do. So, again, that's me. Please get in touch if you have any questions about this talk or anything else you'd like to discuss. I'm going to be around the rest of this day. Please come and say hello. If it looks like I'm talking to someone else, just wave at me. I'm happy to be interrupted. Thank you very much for listening.